Okay, and with the previous topics, actually we have discussed about FM demodulation techniques. Now we'll discuss about FM transmitters. FM transmitters, and to discuss about the topic FM transmitters, actually we have considered all the required components. And FM transmitters means we have to consider what are the different methods for modulators. So in the 5th unit, actually, according to the syllabus, in the 5th unit, you are studied about FM generation methods like direct method or indirect method. So here I'm using the block of FM modulator. Okay, and based on our possibilities, you can use either direct method of FM generation or indirect method. Only modification is in the FM direct method we will use the reactance modulator. In the indirect method we will use the frequency multipliers in the implementation. So here for the sake of representation I am using only FM modulator, and the block diagram for the FM transmitters is starting from the modulating signal M of t. The very first block is a pre-emphasis, as we discussed in the previous. It strengthens the higher frequencies because while transmitting there is a loss of higher frequencies are affected with the noise signal. That's why intentionally we are modifying the modern signal with pre-emphasis circuit. And after that, simply I am using FM modulator, and we have to apply carrier signal, and in the place of FM modulator, you can use either reactance modulator according to the direct method, or indirect method of frequency multipliers along with the mixer in the indirect method. Either way you can use to get desired carrier frequency and deviation frequency. And after that, similar to the AM modulation, we'll use the power amplifier. And this power amplifier that may be useful to find how long we have to transmit the signal and how distance we have to transmit. And after that, we'll use the transmitting antenna for the transmission of the content or modulated signal. And now we'll discuss about FM receivers, and which is same as that of AM receivers, and here also we'll use the super heterodyne concept. And compared to the AM receivers, the additional components are limiter, and another one is a de-emphasis. Because of the transmission of FM signal, amplitude may not be constant while transmitting the signal. So here, as far the functionality is concerned, the limiter maintains the amplitude constant. Even though there are some variations due to the transmission, limiter maintain the amplitude constant. So that's why here we have to place this amplitude limiter at a very first stage, or before the demodulation we'll use the amplitude limiter. And de-emphasis, we know the functionality, like it decreases the strength of the higher frequencies. That should be the last stage of the FM receiver. And the block diagram for the FM receiver that can be represented by, this is a receiving antenna, and after that, as usual to the AM receiver, it is RF amplifier, the first stage of frequency conversion, followed by mixer, and another input is local oscillator. These stages are very common both for AM and FM. After that, IF amplifier. So here this is referred as the first stage of frequency conversion. After that, actually we'll use the demodulator, but in this case we'll use the limiter. And we know that the limiter that is useful to make amplitude variations as a constant representations, and it is followed by FM demodulator. It may be balanced frequency discriminator, FM demodulator, and the resultant may be the demodulated signal, but we'll use the de-emphasis, which is opposite to the pre-emphasis, and it is a recovered modulating signal. modulating signal. And similar to the AM, for FM demodulator, from FM demodulator we'll apply the AGC, or from the limiter we will get the DC signal that may be used to control remaining stages. It is a AGC or feedback. So compared to the AM receiver, the only difference is inclusion of limiter and de-emphasis. So remaining block, this concept is a two-stage frequency concept, and we have used the super-heterodyne principle, first stage and second stage. FM demodulator, it may be balanced slope detector or some other concepts to make the frequency to amplitude variations. Even though I mentioned FM demodulator as a single block, so there will use a resonance circuit or differentiator, and after that envelope detector. All these are the part of FM demodulator, and obviously with the envelope detector it produces some DC signal that is used to feed back the signal. And this is about the FM receiver, the block diagram, and the explanation which you have studied in the AM transmitter, the same thing that you can repeat even in this case. The only modification is IF, intermediate frequency for FM, that is fixed at 10.8 megahertz. For AM, intermediate frequency is a 455 kilohertz, and that can be modified for FM. And obviously we know for FM the frequency range is 88 megahertz to 108 megahertz. So this is about FM receiver.